Hello everyone, welcome to Chaudhary Data World channel. Today I am here with new video on partitions in PySpark data frame or RDD. We'll be watching all the details in detail that what partition is, how we can apply on some particular data frame or RDD. All these things we'll be watching in detail into this particular video. So let's get started with the video. This is very vital question and it's a very vital concept in whole Spark or PySpark, that how data is getting parallelly processed. So the answer is partition is the technique with which data is getting parallelly processed. In partition, what it happens that it become parallelly processed. Suppose if you are having a data set of 1,000 rows, and if you are having 5 worker node, maybe you may say. So in those 5 worker node, those 1,000 rows will be divided, and then it will be parallelly executed whatever transformation you have given it as the command. So whole of those transformation will be applied on that 4 or 5 whatever worker nodes you are having on those, and then it will be given as the output. And since all the data has been separated and divided on whole on each of the worker nodes, all of the data processing will happen into the parallel execution. So this is how partition works. Now we are having two very important terms in front of us, that is repartition and then coalesce. Both of these, repartition and coalesce, are similar, or we may say directly opposite to each other. These two are basically the important methods in this whole PySpark or Spark, in which repartition and coalesce we apply. So this repartition, what is it? So it is operation used to redistribute the data across the specified number of partition. That means if suppose if you are having some particular data set, and if you are having a worker node of 10 worker nodes, and if you are having data set which is getting divided into only 5 worker nodes, and you are having 10 worker nodes, and if you want to increase that worker node to till 8 or 9 or 10, by default it is taking up 5 worker node. But if you want to get it executed more faster, or if you want a more parallel processing, then if you need to pass it explicitly that how many worker node it to be used, it will be used 10 when you will give the number as 10. Similarly, what is coalesce? So it's just different, it's opposite of it, that if suppose that was for to increase or decrease the partition, right? That means if you are having 5 worker node involved in the data processing, you may decrease whatever n value you will pass over there as suppose 3, then 3 worker node will only be executing your whole data transformation. And if you are passing over there 10, then 10 worker node will be executing your whole parallel processing. But in coalesce, whatever default it is over there, or whatever pre-existing worker node it is getting executed in that parallel processing, you can just decrease that worker node. Now it's not possible that you can increase the worker node. That means if suppose 5 worker node is executing the parallel processing, you can go below 5, not above 5. That means you can't repartition your data set into 6 worker node. Instead, you will only be repartitioning your worker node to 5 or below 5. So this is how coalesce work, and this is how repartition work. We will jump to our Databricks, and you can just take a screenshot of all these notes whatever I am keeping here, so that you can refer it later. You can get some important concepts from this whole notes. I'm switching to the Databricks now. In Databricks, what we are going to do, we are taking up a data frame. In that data frame, we are taking up data from some particular file. Now that data frame, by default, we will be having some of the partition applied over there. We will watch that what is the partition it is applied over there. And after that, we will apply repartitioning over there. That means we will change the number of partitions. and then we will save the data. We will see how the data is getting saved when the number of partition increases or decreases. And again we will use coalesce so that we can see that how we can use the decreased number of repartitions. All these things we will be watching one by one. So just come here and just you can see that we have taken up df underscore file, right? This is getting applied by this as spark.read.csv. It's simple. If you are aware, I will just do it something like shift plus enter, so that in front of you your data frame will be ready. Let's see. So this data frame is ready in front of you. Now what we will do, we will just see that this particular data frame, how many in how many partitions this whole data frame has been divided. For that, what we will be doing, we will be taking up a new cell over here. We will taking up this particular code. This code is responsible to give you that how many partition it is applied over this particular one, this particular df file. So this df file we will pass over here. What it is now, it is telling you that it is just changing it to rdd, then it is taking up the get number partitions. How many number of partitions it is there, it will be getting. So when shift plus enter, you can see that only one, it is only have partitioning the whole data set into only one worker node. That means only one worker node or only one virtual machine will is responsible to execute whole of this data transformation in this particular data frame. Now what we will do, we'll move ahead and then we will repartition this whole data set, that is df underscore file, in 4 worker node. Now since we are having into our cluster, we have assigned that it should be 4 at least. So what we will do, we will repartition this whole data set, that is df underscore file, to 4 partitions. Shift plus enter, you will see that it has been repartitioned, and that data frame which is repartitioned is called df underscore repartition. Now just to check if it has been repartitioned or not, what we can do, we can again execute this command, that df underscore repartition, and that get number of partitions. So once we will execute this shift plus enter, it should ideally give you 4, and it's giving you 4, right? That means you have repartitioned it into the 4 partitions, right? What we will do now, we will apply some of the modification on the data frame, and then we will save that whole data frame into dbfs. We will see that how when we are saving it into the 4 number of partitions, how is it looking. Then we will remove those files. We will then again apply coalesce, and then again we will save the files, so that you can have a clear understanding that how the files are getting generated. We will apply this whole transformation. In this transformation, we are doing nothing but we are doing concatenation of this category column and then subcategory column by importing a concat function and lit function from this sql.functions. Once that is all done and all set, this df underscore file underscore modified is the data frame in which whole of your transformations has been applied. Now moving ahead, what we are going to do is we are just going to have, you can see that whole of the transformations has been applied on df.partitioned. That means whatever number of partition that was 4, the data frame was, so that data frame, that particular data frame we are applying on that particular data frame, we are applying whole of the transformation. Moving ahead with having saving of all or generation of the file which is a transformed data frame. Whatever transformed data frame you are having now, those data frame will should be generated into some CSV file. So for that, what I have done is I have just taken the file path as mnt dbfs. Till here it's the typical boiler code, that it's dfs. Here in dbfs it is going to save with having one folder created over there, that is my folder. Under that my folder there is my file.csv will be a folder in which it will be saving whole of the partitions generation of the data frame. Whatever the data it is generated in each of the partitions, it will save over there. That's it. So we will again shift plus enter. It will not, it should regenerate the file. Now you can have this particular path on which we will be checking if the data has been generated. So we will navigate to dbfs, we will navigate to mnt. It is telling to select the cluster, confirming its once. So you can see that dbfs is now available over there. It takes a bit time to just, or else what we can do, it's taking UI is taking time. So what we can do, we can just come here and then shift plus enter, so that it will list out whatever files it is over. So it is my files.csv over there. So what we will do now, we will just come here, copy this particular one. We will just check that what this my file.csv is containing. It should contain ideally 4 partitions, right? So here you can see that how many number of files now it is containing. So it is containing all the partitions, like you can see that where it went. So it should be, it is part 03, part 02, part 01, part 00. So what you can see that all the partitions whatever we have given, that means there were 4 partitions to be done. That means the whole data frame will be having transformation basis of the 4 worker nodes. So all of those 4 worker nodes are throwing out the separate files, that is part 00, part 01, part 02, part 03. This is how, when you are partitioning your data frame except one, that means you, when you, above one you are doing, you are having multiple files, that means multiple transformation file you are. So come up with the solution that how it can be merged into one particular file only. For that, what we can do again, we will just first remove all these files so that we can have a clear understanding. So it has just removed that particular one. Now we will apply this df coalesce. So what we will do, since our df underscore repartition data frame is containing the partitions in 4 worker node, what we will do now, we'll pass this particular code that will, what it will do is, it will just coalesce this df underscore repartition to the one worker node, correct? So once we execute this, that whole one partition data frame will be this df underscore coalesce. Now this particular one will pass over here, so that we can have that particular one partitioned data set into it. And once it is done, we can just click on shift plus enter, so that whole of the transformations will be applied over there. And once that is done, you need to just go here and then you need to click over the generation of the file. So it will again generate file, and this time into my file.csv there should be only single part. It, apart from 0, 1, 2, 3, it should only be one file over there. So now we will do dbutils.fs.ls. So you can see now, right? You can see that only this part 000, this particular csv is only generated. This time it is not like that it is 01, 02, 03. That means when you are having multiple partitions, it is generating multiple files. If you are having one partition, it is generating one file. Now hope that you are very much clear about these two concepts, that is repartition, coalesce, what is partitioning, how we can apply over it, each of the data frames. And if any confusion, let me know into the comment section. If you found this video helpful, kindly like to the video, subscribe to the channel. See you in the next one.